world, it can become worse. But I only hope, because the interest is there, the FTB program will become much more. I'm happy when Aparajita said lots of people who participated would like to participate, kind of a framework or the other. So I'm extremely happy. And then this is also an age of machine learning. And I think the soft computing and the machine learning, it's very important. People get confused from the machine learning as well as the artificial intelligence. And we are not mimicking in the machine learning, we are not mimicking any human intelligence. And that is a point what one has to understand. And that is where you have lots of patterns that is being fitted, and how this plays a very vital role for varieties of things where you are going to collect the data and you have varieties of learning. And I think this one is something people, and particularly the ICT Academy, has to make clear for all the students. And then do not confuse with AI and machine learning in a language perspective or the other, even though machine learning can be told to say it mimics AI, but that is not the objective in the machine learning. And it has lots of linear algebra, lot of mathematics that is involved. And I think it's essentially we are coming back to continuous mathematics as compared to the discrete mathematics, which most of the computer science people were worried about. And in the past decade, actually, we have grown. And this is an important aspect to the ICT Academy. In the age of AI and machine learning, it's important they give the foundations of the linear algebra in a very, very effective manner, because that is the basis from which it is not just to use a TensorFlow from Google or something or the other. It's very important to understand what is it the pattern we are fitting. Otherwise, you can always fit a curve. In a large sense, machine learning is nothing but curve fitting. That's how physicists, chemists, and everyone likes it, kind of a framework or the other. And this is a part I would like IC2 to play a role, and hopefully the IEEE Computer Society will provide you all the support that is needed. And I wish you and the organizers as well as the participant a good success in the FTB program. And hopefully you would learn something, and that is a feedback perhaps that what one has to give, that itself can be some kind of a reinforcement learning to give to the next set of people, kind of a framework. Thank you. And again, I wish you all the best. Thank you.
Thank you, sir. Thanks you for your nice word. I would like to request Professor Kusumdeep ma'am, please say a few words about it. Kusumdeep ma'am, please. I think.
Hello. Can you hear me?
Yes, ma'am, please.
I wish you all a very good morning, and I would like to thank the organizers for inviting me for this FDP. It's really indeed a proud moment for me to get associated with this FDP. Thank you so much. Regarding the soft computing, I believe that in today's world, where we are challenged with solving real life problems, soft computing is one such area which is going to lead the future. And no matter whether it is machine learning, deep learning, data analytics, big data, optimization, you name it. Any such area of application where these tools are used will sooner or later be making the use of soft computing techniques. So as you all know, the participants, that soft computing is a emerging area which is divided, I would say, into three categories. The first one is the evolutionary and swarm intelligence based algorithms. The second one is the neural networks. And the third one is fuzzy logic. So, with these three broad classifications, we try to solve real life applications, particularly where the traditional techniques fail, and it is a challenge to solve these real world problems. So I really congratulate the organizers for organizing this FDP. It's very timely, and I hope all the participants will really benefit from it and they will enjoy each and every moment of this FDP. It is my pleasure to deliver my talk on nature-inspired optimization techniques, and I hope everybody will listen to that and interact with me. Thank you so much and wish you all the best.
Thank you, ma'am. Now I would like to request Dr. Kusum to present the vote of thanks. Dr. Kusum, please.
Yes, sir. Yes, sir. Once again, good morning to all of you. I, Kusum Bharti, regard this as an honor and privilege to extend vote of thanks on this occasion. Today, I have this opportunity to put all my gratitude in a form of words. On behalf of organizing committee, I would like to thank our institute director, Professor Sanjeev Kumar Jain. His support gave us lots of encouragement and do our best every time. He is not able to make it because of some unavoidable situation. Because of that, he is not with us in this current inaugural session. But yes, constant support of him may make us to do best each and every time. On behalf of PDPM Triple ITDMJ family, I would like to thank our guest of honor, Professor Shyam Sundarji, for taking his precious time out and consenting to be the guest of honor of today's occasion. I would like to thank Professor Aparajita Ojha ma'am and Dr. Atul Gupta sir, who grace us with his presence and guidance. Thank you so much, sir and ma'am, for sharing with us your words of wisdom. I would like to thank Professor Kusum Deep ma'am from IIT Roorkee for being a part of this inaugural session and sharing a very brief introduction about what this soft computing is all about. I extend my sincere thanks to non-teaching staff for their enormous cooperation in the starting of this event. I extend my sincere thanks to Atal Academy for providing us the financial support, and IEEE Computer Society and Signal Processing Society for their support in organizing the event. Last but not the least, I would like to thank to all the participants. Because of them only we are able to organize this program. I once again thank everyone present here for being a part of this program. Thank you so much. Over to you, Manish sir.
I think Manish got some power disconnection.
Okay.
So you can continue from here.
So basically the first session, we are going to start the first session from 10 o'clock, and this session will be taken by Dr. Jagdish Bansal, and he is going to talk about what this particle swarm optimization is and how it is going to solve the problem. So we will resume the session from 10 o'clock.
Thank you, Kusum.
Thank you so much, ma'am. Thank you.
Yeah, thank you, the two coordinators, and I hope that this is going to be a very learning time. It's a very excellent kind of topic and very relevant from today's standard. So I hope the participants will make full use of whatever is the expertise and the material that is available. So good luck and best wishes to all of you.
Thank you, Kusum.
Thank you, sir. Thank you.
Thank you, Professor Shyam Sundar, also like joining us and encouraging us to begin with a big note So your presence always like motivates us, and I can assure you that we will do a good job here, interacting with participants in this online mode, and ensuring that they find it useful for their time.
All the
For
best.
those, yeah, for those who do not know, we would like to tell that we were very fortunate to have a legend like Professor Shyam Sundar in our board of governors, and that was a very good board of governors. We got so much of guidance and mentoring, and Professor Shyam Sundar's role in bringing up this institute is. Uh, I mean, cannot be expressed in words. We really are so thankful to you, sir, for your presence today. Thank you.
Thank you, Aparajita, for all the laurel you are telling me, and also all the trouble you have taken in building from a very nascent stage, which is remote, kind of a framework or the other. Wish you all the best. Hopefully, sometime I will come, and also I'll thank Atul, also see the department. Though I was on the board, somehow or the other, I never made it because
Yes.
for whatever reasons it is. Thank you and all the best. Thank you. Bye.
Bye.
Thank you, sir. Thank you.
So Manish is back, I guess.
Yes.
Yeah, Manish. So I mean, be prepared about these power cuts. So better is like use a laptop with a battery backup and internet connection without, which is based on power. Okay.
Okay, sir.
Good. Good. Hello, I'm leaving. So
Okay,
all the
sir.
best.
Thank you.
Thank you. So, dear participants, there are few announcements before we are going to start our session. And these announcements are that one thing is that according to the AICTE norms, 80% attendance is compulsory. So for that attendance, what we are going to do, you can write your name on the chat. So we are going to consider it as the attendance in this course itself. So it is requested that you should write your name in each of the session in the chat, and we have to upload this chat, your attendance in the Atal portal. So that chat we are going to consider as a attendance, and we will upload that on the Atal portal itself. Another thing is that as per the norms, we have to take a examination in this course also. So we will conduct a quiz, online quiz on last day of this workshop. It is going to be a objective type question paper, and it will have 25 questions of 100 marks, and it is decided by the AICT that you should have to score 60% on that. So consider for that examination also. And one more thing is that you have to give your feedback also on the Atal portal itself. So please fill your feedback on the last day, and then your certificate will be generated on the Atal portal itself. You can directly download it. So we are not going to mail it separately. You will get your certificate from the Atal portal itself. If you are facing any problem, you can contact us. We are here to help you. And in this course itself, if you are facing any problem, you can directly call on our mobile phones, or you can mail us also. Fine. So our first session is going to start at 10, and Dr. J.C. Bansal, who is Associate Professor in South Asian University, he is going to take your first session, and hopefully you are going to enjoy the this learning process. So, and I would like to say one more thing that please don't share your screen. Fine, because that is not a good thing, and only the speakers are allowed to share the screens. So I am assuming that you will be having a good manner, because all of you are also teachers and we are also teachers. So you can think of if anybody is doing something wrong, then definitely it's a problem for us. And uh, thing is that although if you people needs, we can create a WhatsApp group also. But if you think that there is no need of the WhatsApp group, then it can be also avoided. You can mail us and you can directly call us also. So there are some suggestions that we should create a WhatsApp group. So what we will do, we will create the WhatsApp group by today, and all of you will be part of that, and then we can have the this discussion on that also. Fine. And for online examination, you have to make your profile on Canvas. Today itself, we will provide a link of the Canvas where you can make your profile, and your examination will be conducted on Canvas platform only. Kusum ma'am, do you have anything to say?
Yes, the materials which we are going to have in during these sessions, the material I am also going to upload in the Canvas only. So from there you can download it easily.
Okay, so we are just in a few minutes, we are going to start our new session. We are waiting for Dr. JC Bansal. As soon as he is going to join, we can. One question is that how you are going to access Canvas. Canvas is a platform, so we are going to provide you a invite. From that invite link, you can create your Canvas profile, and then you can perform all the operations. Your materials, your question papers, even your marks and all those things, you can see it on that Canvas itself. We will send you today the link of this Canvas invite. So now we are having Professor Bansal with us. uh, Canvas is a platform. Canvas is an online platform. Like you have heard about the Moodle, or you so whatever the facility you are going to have on the Moodle, same facilities are also available with the Canvas. Canvas is also a open source software, and it is widely used. Even in our institute, we have conducted our previous semester on this Canvas platform itself. All the examinations and all those things has been conducted on online through the Canvas platform itself. It was very easy, very friendly, and the data requirement is also very less. So we have used this Canvas platform, and in this semester also now we are having two platforms, Canvas as well as Moodle. So we are trying on both of them also. So it's a good. So I will recommend that even in your college schools, if you can use these kind of platforms to have the online classes, to sharing the materials and conducting the online examinations also. So you will see that in these platforms it's very easy. Even it is not compulsory that you should only organize the objective questions. You can even give them to write the subjective questions, which they can write on the computer screen, or you can give them a take-home type examination where they can got this examination, and then upload the files. So we are going to strict on the Canvas itself, which we have already used for last 6 months. So we are not going to shift to any other like Google Classroom or any other things. Question is that whether the screen will be freeze, it depends on the instructor. So instructor has to make the kind of functionality, whether you want that pupil should look all the questions at one time, or they should see one question one by one. They can go back, they can move forward. All these things will be controlled by the instructor itself. So all these informations will be shared with you, that what conditions we have put on this examination itself by the time. So you don't have to worry about that.
We can start the session. Bansal sir has joined.
Okay, so I would like to ask Professor J.C. Bansal, who is joined us, and he is going to take the first session. Professor J.C. Bansal is an associate professor at South Asian University. He has vast knowledge in the field of the soft computing. He has written many books on it, and he is the editor of many reputed journals and the reviewers also of many reputed journals in the field of the soft computing. I would like to request Professor Bansal to please share his screen and share his knowledge of the field with us also. Professor Bansal, thank you.
Good morning, Professor Bajpayee, and good morning, Kusum. I hope you can see me. My hello. I hope you can see me. Right. So just give me 30 seconds. I'm joining with one more device, and I'm sharing the screen with my other device so that I can write with my Surface Pen also, right? So that things may be more interactive in that way. Just give me a minute. So I'm just sharing. I'm joining this link with one more. So I hope now everybody can see my screen. Kusumji, you just please confirm.
Yes, sir. We are able to see.
Okay. So good morning again, everybody, and thank you, Dr. Kusum, the organizers of this program, for giving me the chance to speak on my favorite topic in the swarm intelligence, that is particle swarm optimization. I started my career in swarm intelligence with this algorithm, so it is always closest to my heart, the topic. So just let me start my talk with my introduction of my university. It's a less known university, so usually I feel that I start the introduction of my university. I'm in South Asian University. It is the university established by 8 member nations of the SAARC, including Afghanistan, Bangladesh, Bhutan, India, Maldives, Nepal, Pakistan, Sri Lanka. We started our campus in Akbar Bhavan, which is the old building of the Ministry of External Affairs. And we started this university in 2010. My department started in 2012, and I also started from 2012 itself. We all started this department. We all are the current members are the initial members of the department. We have only the PG and PhD courses because we are the research-based university, so we don't have any course on undergraduate course. And our permanent campus is upcoming in Maidangadi, which is in the South Delhi, near to IGNU. So most probably next year now we will shift. We plan to shift this year, but because of this pandemic, all the plannings, everybody's planning changed. So our planning was also changed. Okay, so let me start with this particle swarm optimization. So that will be my planning. I will first of all explain about the swarm intelligence, and then particle swarm optimization, and then okay. First of all, I'll talk about the swarm intelligence, detail about the swarm intelligence, what is this, and some popular algorithms in this category, and then particle swarm optimization. I will explain, and if the time will permit, I will also consider few variants of particle swarm optimization, so you can understand that how this algorithm is modified, and you can also have an idea to modify this algorithm. Okay. So when I say the swarm intelligence, actually the swarm intelligence is a part of the computational intelligence. So what is the computational intelligence? So let me start the definition of swarm intelligence by defining the term computational intelligence. So in short, the study of the design of intelligent agents. In computational intelligence, we study the design of intelligent agents. Now, I hope you understand that intelligent agents, anything may be intelligent. You know, this pen is a object, and it may be intelligent and it may not be intelligent based on certain criteria which we define. We can define a 5-year-old boy intelligent and a 50-year man intelligent based on the requirement that what is expected from a 50-year-old man and what is expected from the 5-year-old child, right? So we define our requirements. So accordingly, we can define the requirement on this pen, and accordingly we can say that this pen is intelligent or not. That is, you know, the application specific intelligence is there, and this intelligence can be artificially inserted to a device, to an object, to a non-living thing. For example, we can understand the human's behavior, we can understand the ants behavior, birds behavior, any other animal's behavior. We can understand and we can observe that behavior, and if that behavior is can be modeled in some I think there is some request that okay, there's some message that can you share about the soft computing. Okay, let me just complete this definition. I'll start with the word soft computing. That's right, good choice, according to the theme of the workshop also. Okay, so let me complete this definition. So what I said that if we can understand the living creatures behavior and can convert to a mathematical equation, some computer algorithm, or some step-by-step procedure, if we can put the living's behavior, then sometimes it may be possible that behavior can be inserted to some non-living things, so that non-living things can start behaving like living things, right? So this kind of insertion of intelligence which is inspired air from the nature, which is inspired from the nature and is inserted to some non-living thing. In this kind of studies, where we make the non-living things or non-intelligent objects intelligent through iterative computation. Through iterative computation means that that step is applied many times on that object, and that's why that object becomes intelligent. Right? It's a computational intelligence. Please mute yourself. Uh, it is creating disturbance. Kushal Patel, I think. Please, please mute yourself. Okay. So the in the computational intelligence, we study how to design those intelligent agents. Now, this agent may be anything: a laptop, a pen, a Alexa device, Google Home device, whatever kind of things we can, or a robot, a drone, whatever can be the agent, and we can make them intelligent for a given specific task. Remember, we the human beings are also intelligent for a given specific task. We are also not general intelligent. Let me tell you, I'm not a good truck driver. I cannot be a good truck driver. I can be a good teacher only in my subject, but I cannot be a good truck driver. And a good truck driver cannot be a good teacher. He may not be able to explain you the swarm intelligence the way I can explain. So, we are also trained in some specific task. And that's why you may say that, okay, Jagdish Bansal is intelligent in this task, that person ABC is intelligent in this task. So similarly, actually what we can do, we can make the agents, the non-living things, the robots, the drones, the watch, these days the watches, the mobiles, the laptops, is specific or intelligent for a given specific task. We can give, and of course we can make them intelligent for more and more tasks. But you cannot say that any agent can become a general intelligent, the general artificial intelligence. So it is actually theoretically true. General artificial intelligence is theoretically true, but not actually. It is not the practical approach, right? At least in these days, it is not practical approach. So in order to make the agent intelligent agent, what is required? We can observe certain things about ourselves, and then we can insert those things to that agent. So here the third, you can see here this third box. You can see here this third box is about the observation of the things what we have, so that you can say that the human beings are intelligent, right? How a human being is intelligent. Just for example, I'm considering an example of a human being. So an intelligent agent, suppose a human being is intelligent, then why he's called intelligent? Because whatever it does is appropriate for its circumstances and its goals, right? So a truck driver is not attending all these online webinars. Whatever the lockdown or something, we are utilizing this time in attending webinars, giving webinars, learning new things, writing new research papers. We are utilizing this because we are into the research and teaching career. This is our job, right? So we are doing this. But truck driver is not utilizing this time in doing this. He's driving the truck, right? So the humans, and he will not attend, even if you will pay him. Okay, we are paying him, we are not charging, but we are paying him, suppose rupees 500 to attend per lecture. And if he's getting rupees 600 for the truck driving of the truck, then he will go to the driving of the truck, because he will get that, okay, I'll earn that money there. And this is not useful. So whatever the intelligent agent do is can consider that whether it is important for me, whether it is beneficial for me or not, right? The first thing. Another is, it is flexible to changing environments and changing goals. What is the better example than this pandemic or this situation? We all, I never taught online except when I was in BITS Pilani. I taught few online courses. Bits Plani runs some online courses. So, but that was just few classes, and I was not very habitual of teaching online. But nowadays, you can see that we, the humans, we being are so adaptive of the changing environment. Environment changed, we changed ourselves. We started to attend the online lectures. We started to give the online lectures, and that with almost equal efficiency. Almost equal efficiency, we started to give the lectures. So actually, what I want to say that the intelligent agent is always adaptive for the changing environments. It learns from the experience. This, in my opinion, this is the one most important component which makes any agent an intelligent agent. This one is the most important agent. Property which makes any agent an intelligent agent, that it learns from the experience. If you have a 5-year-old child and a 50-year-old man, then you can always expect the better answers or better experience, better decision making from the 50-year-old man as compared to a 5-year-old child, because you expect that he must have learned more than the 5-year-old boy, 45 years more than the 5-year-old boy. So he has more experience, because we all learn from the experience. That's why, the senior people have more salary, junior teachers has less salary, assistant professors has less salary, and the full professors has more salary, because the system understand that these senior people has more experience. So they should be rewarded more, right? And they have the more experience, more knowledge. So we all learn from the experience. So similarly, the system also learn with experience. I hope now everybody of you must have experienced about these mobiles. Whenever you buy a new mobile, you must have seen that uh, my name is Jagdish. So whenever I started to type JA, when I bought a new mobile, when I buy a new mobile, it doesn't predict Jagdish. But when I started to use it for 1 year, for 1 month or so, it started to predict Jagdish, because deep learning, of course, deep learning based algorithms are there. Computational intelligent algorithms are there. Deep learning is one of the computational intelligence algorithm. So are there. These all the modern mobiles are deep learning enabled mobiles. So they learn from the experience. Many times you have written JAGDISH. So whenever it learns that, okay, this user, whenever he writes JA, this much number of times, whenever he writes JA, he completes the word with Jagdish, right? And therefore, the system itself started to predict Jagdish, right? So the system learns from the experience. So you understand that this property is there in the systems. Similarly, robots can be trained in such a way that they learn from the experience. Another property is that it makes appropriate choices. It makes appropriate choices means if there are more than 2 alternatives, then the decision should not be random. Decision should not be random. Actually, it should be based on some logic. Suppose there is a junction. Here is the junction. Here, I am here, and there are 2 men. One is the 5-year-old child, and one is the 50-year-old man is here. Now, if 5-year-old boy say that this is the correct way, and 50-year-old man say that this is the correct way, I'm asking which is the correct path, or which is this address, from which path I need to go to reach at this address, and this is the junction from where I need to go. Then 50-year-old man says different answer, 5-year-old child says different answer. Then of course I should believe on the 50-year-old man, because I understand that he has more experience. He he has more experience, so he should go. I will go with the 50-year-old man. Means that I am behaving intelligently, and I'm putting some logic. When I have two choices, this choice and this choice, two choices, then I'm considering this choice because of certain logic, not just random. So this is the intelligent behavior. So actually I want to say that if we can incorporate these four properties into a system, then we can make a system intelligent system, right? Of course, this making appropriate choices, learning from the experience, what to learn about that specific task, whatever you have defined, about learning about that. Okay, so I just read few chats here that there are certain, what is the real life example of just like deep learning in mobile? Okay, so many questions are here, and soft computing is a part of artificial intelligence. Let me answer all these questions. Just hold on, please complete me this thing, and I'll definitely share what is the application of PSO or all these kind of algorithm. PSO is one of the most applied algorithm. Just hold on, I'm coming to that, right? And I'll be happy if you people make it more interactive by questioning, and if there are questions, if you want to unmute yourself and can speak, that is also okay for me, but please make sure only one at a time, otherwise there will be an echo, right? So the computational intelligence, the study of the design of intelligent agents, and so computational intelligence, the first thing is the computational intelligence is the part of artificial intelligence. I'm coming also in that. So here if it is AI, then this is your CI. So CI is the part of artificial intelligence, right? Artificial intelligence is the intelligence which is obtained artificially, and when this artificial intelligence is obtained through iterative computation, what I said, when artificial intelligence is obtained through iterative computation, this is very simple and complete definition, through iterative computation, then AI becomes CI. Then AI becomes CI. If AI, artificial intelligence, if the intelligence which is obtained, if the artificial intelligence is obtained through iterative computation, you must have seen, you people are attending this, so you may be aware about the neural networks, you may be aware about the other evolutionary algorithms, swarm intelligence algorithms. So all these are the iterative algorithms, right? So this iterative computation is the iterative computation of artificial intelligence is known as the computational intelligence, right? So let me just before considering those slides, let me complete this slide. You can understand now in this figure, you can well understand that what is the PSO, or what is the swarm intelligence, or what is the artificial intelligence. So let me tell you that artificial intelligence, I hope everybody of us know, then the computational intelligence is a part of artificial intelligence. I just mentioned that when this CI becomes AI, AI becomes CI if the intelligence is obtained through iterative computation. Now the swarm intelligence is a part of computational intelligence. Means swarm intelligence is a kind of computational intelligence, and this when the computational intelligence is obtained, the intelligent behavior, computationally intelligent behavior is obtained by cooperation among the individuals. Of course, iterative computation will be there, but this iterative computation is based on the information sharing among the individuals of a swarm or of a group. A group of individuals, when share the information with each other, when they help each other, when they cooperate with each other, then whatever is the intelligence emerged is the swarm intelligence. So I hope, and of course, PSO is a part of this. PSO is this. This is your PSO. So now I hope I have explained that where we are studying. If I'm explaining about PSO, what I'm explaining, actually I'm studying the artificial intelligence, a part of artificial intelligence. If I'm studying PSO, I'm studying a part of artificial intelligence. So artificial intelligence, then computational intelligence, then swarm intelligence, and then PSO, of course, right? Yes, deep learning is also CI. Yes, that's right. So, okay. The general framework of okay, any example of AI which is not computational intelligence? So yes, and you know the artificial intelligence means any other kind of heuristic you have defined. Suppose you have defined the robotic path planning problem. Suppose robots path planning problem you have defined. I'm giving you an intelligence that okay, here is the source location and here is the destination, and here are certain obstacles, and he has to reach here. The robot has to reach here destination. So what he will do, you define that okay, you keep on moving straight with whatever is your direction, you keep on moving straight, and whenever you have an obstacle you take the left turn and then keep on moving straight, and whenever you have an obstacle take the next left turn, and when keep on moving this whenever you have another obstacle, suppose another obstacle, then keep on moving left, right? So this kind of heuristic we can define. There is nothing like intelligence here, nothing like intelligence, just fixed set of rules we are giving to this rule. So you can call this as one artificial intelligence. Of course this intelligence is there, some kind of artificial intelligence which is not through iterative computation, which is not learning from the environment, right? And of course you can understand that the artificial intelligence is a very old term, and this artificial intelligence which we used to use before 90s is most of the time not computational intelligence. Through not, you know, when I say the computational intelligence means iterative computation, that too very intensive iterative computation, thousands of the time I'm taking the iterations. For example, the neural networks, let me consider the neural network. So we are training our system with lots of data, right? And then we are testing, and then we are applying this whatever the trained system is to answer the question. So iteratively we have made this system very intelligent by making lot of data, right? So when I say computational intelligence, lot of computation we have done in background, and then we made a system intelligent. If the computations, if the iterations are too less, that can be done by the hands also, means the computer devices are not required, then you may say that it's not intensively computationally intelligent, intensive computationally intelligent, right? Okay. So let me come to here the the general framework of the all computational intelligent algorithm. General framework. This is the general framework of all the computationally intelligent algorithms. CI, all the CI algorithms, not only SI, not only SI. I hope now I will keep on using these words: AI, then CI, and then SI, right? So you understand that AI, artificial intelligence, computational intelligence, swarm intelligence. So just please be familiar with these words of artificial intelligence, computational intelligence, and so on, right? Okay. This is the general framework of all the computational intelligence. All the computational intelligence, whether it is neural networks based algorithms, swarm intelligence based algorithms, evolutionary computation based algorithms, all those algorithms follow this general framework. So here there is an agent, and I want to make this agent an intelligent agent. Let me tell you, I want to make this agent an intelligent agent. How to make that intelligent? I told that in computational intelligence, we make this agent intelligent through iterative computation. So here the agent takes some actions. Here the agent takes some actions. Now these actions, let me tell you that these actions in, suppose the Newton-Raphson method. I hope you remember the Newton-Raphson method. It's I think undergraduate or 12th class course. You know about Newton-Raphson method. So in Newton-Raphson method, you take you want to make, suppose, the initial guess a better solution. Initial solution, whatever the random solution initially you take, which is this agent, you want to make this a better solution. So what you do, you make this agent new solution by making some changes to this, right? By making some changes to this. So this is the action that you have taken on this initial agent to make this better agent, right? And this action, this action is taken based on some mathematical properties, based on some mathematical of course this is at initial, right? So you have taken this action based on some mathematical background or some mathematical concepts, right? Now, in the computational intelligence algorithm or in the artificial intelligence algorithm, this action, this H, is not necessarily mathematical, is not necessarily inspired from mathematical derivation, or is not necessarily derived from the mathematics. This action is not necessarily derived from the mathematics. This action is not necessarily, this H is not definitely necessarily. It may be derived from the mathematics also, but not necessarily derived from the mathematics. It may be some random action also. Random action also, it means initially the agent, in order to learn, can do some random actions also. For example, suppose you want to learn the soft computing and you have you do not know whether the course organized by Kusum is good, or the course organized by some other faculty is good. You want to learn that, and you don't want to waste your time. You want to optimize your time, right? So you may randomly can attend any one course. So you have attended this course by Dr. Kusum. So you then, if you found after attending this course, this is the environment. You learn this. You encounter with the environment after taking this action, and then you observe. You observe that, okay, this is a good course or this is a bad course, whatever. Your goal was to, you will compare whatever you become now after attending this course, whatever you observed, whatever you become now, whatever you learn from this experience by attending this course. There may be many actions. There may be infinite number of actions. For this agent, there may be infinite number of actions, possible actions, or finite number of possible actions. This depends upon the search space where you are modifying your agent, right? The search space in which you are allowing your agent to get modified, right? So here it will observe whether I learned this soft computing or not, and you will compare that my goal was to learn, becoming expert in the soft computing, and whatever is my past experience and prior knowledge. This is not the current situation. Just hold on for this. I'm coming to this. But this agent, after taking a random action and learning from the environment, it compare after he observes. Now he has knowledge about that particular action. So then he can compare with its goal and then become slightly intelligent. No matter whether you will learn soft computing by attending this course or not, but at least you will learn this thing that you cannot learn soft computing from this course. By attending this course, you can learn the soft computing, or either you can learn the soft computing, or you will be learning that by attending this course, nobody can learn the soft computing. At least, so learning will always be there. So whatever is this action, learning will always be there. So actually, no action is the worst action. No action is the waste of action. Either you will learn something, either you will learn that this problem can be solved using this way, or you will be able to solve the problem. There is a famous story about the Alexander Fleming. If I'm correct the name. So thousands of the time when he was in making of the penicillin, he tried thousands of the time. So some of his friends told him that don't you think that thousands of the times you failed, so you may not be able to make the penicillin. So means your all the efforts gone waste. So the Alexander Fleming answered that no effort gone waste. Now I learned that the penicillin cannot be made by these 1,000 ways, right? So in the computational intelligence, no action is a waste action. However, it is this action, this agent is taking random action, but if this action is a wrong action, then it is also not a waste action. The agent learned that the problem cannot be solved by taking this action. So it is a memory based algorithm. The agent will keep in mind that I have taken that action and that was failed, so I will not do that action again. So the Alexander Fleming will not repeat those 1,000 mistakes. You do this daily. We all are the researchers. We do this thing daily. That whatever the action or whatever the experiments in our whatever the numerical experiment we do in this PS or in these things, then if they are failed, we will not repeat them. We do not repeat them. I hope you understand this. Okay. So here now this agent will learn something with this action. Now this will take another action. Suppose H dash. It will take another action, and now this agent will take another action, and another action. Remember, and another action. It will not be the repeat of the previous mistake. So any random number or any random action which is now generated must be different from the previous one, right? So and then we'll encounter with the environment, learn from the environment. Means, for example, suppose you have learned nothing, or you have not achieved your goal by attending this course. Then you will attend some other course, right? Some other course, and then you will again learn, and then you will compare this thing with your goal and observation. But now you have your prior knowledge and past experience that you have attended Dr. Kusum's course. Dr. Kusum's course you have attended, and you have some knowledge from that. Maybe knowledge that the course cannot be understood by this, or past experience that okay, these things now it has, because it has taken the previous action, right? So now based on this agent will become another, some slightly more intelligent, and this process continues. So all these iterations continues, and the agent will become keep on becoming intelligent. This is the same way how we become intelligent. We the human being becomes intelligent, right? I hope I'm clear till now. Of course, I will take the questions, no worries. I will keep on taking the questions as the situation comes. So where we study the computational intelligence in general. So my answer is not only this. My answer is everywhere. Wherever you have a problem, you can utilize the computational intelligence. Computational intelligence is everywhere now, whether it is science, engineering, agriculture, medical, whatever the area you see, you can see the application of computational intelligence, application of the artificial intelligence. Of course, the application of one that specific problem may not be application of a specific strategy or application of a specific algorithm may not be utilized everywhere. Okay, so just may tell you that swarm computational intelligence algorithm can be broadly classified into swarm intelligence based algorithms, artificial neural network based algorithms. So all the GAN or deep learning or GAN or ANN, all these kind of algorithms comes here. Then evolutionary computation, genetic algorithm, evolutionary strategy, differential evolution, BBO, biogeography based optimization, all those algorithms comes here. Then the artificial immune system, and then the fuzzy system. So I'm not these all topics are not of my interest right now. I will just concentrate on the swarm intelligence for time being, and particularly the particle swarm optimization. So before I move to particle swarm optimization, let me just quickly tell you about the definition of the particle swarm, swarm intelligence, the formal definition of the swarm intelligence. So let me tell you, this is the Bonabu who gave this definition, formal definition of swarm intelligence in 1999. This formal definition is one just few words definition, but let me tell you, this completes completely explains the concept of the collective swarm intelligence. So the very first word is, the swarm intelligence is the emergent collective intelligence. First thing is, it is the emergent intelligence. First thing is this, it is the emergent intelligence. You can emergent intelligence or emerged intelligence, right? Emerged intelligence means it is not inherent intelligence. Inherent intelligence is not there, means the swarm intelligence is obtained through iterative computation or through cooperation among the individuals. For example, suppose, just imagine, I know that many of you already know the swarm intelligence, many of you already know something about the particle swarm optimization. So you may not all may be getting full benefit of whatever I'm telling you, right? So, but you know something and I know something. I know swarm intelligence, so I'm sharing my knowledge with you. You know another topic of the knowledge, and I will attend your seminars or your webinars, and then I will learn those things. You know one thing, you have one knowledge, A has one knowledge, right? And B has one knowledge, right? They share the information with each other. They share the information with each other. So now, after sharing of the information with each other, A and B both have both the knowledge, K1 and K2, right? So both become more intelligent. So the intelligence is emerged by the sharing of the knowledge. So it's an emergent intelligence. Another thing is, it is collective intelligence. It is collective intelligence. It is not the intelligence of the individual. It is the intelligence which is obtained through collective efforts. Through collective efforts, all have efforted. You have made some efforts. I made some efforts, and that's why we all become intelligent, right? So this is the way how we, the human being, are fighting with all the changing environments. The big so big creatures, the dinosaurs die out from this earth, but the humans, the ants, are still surviving. Human beings, the ants, the fish, they are still surviving on this earth because they have the cooperation mechanism. They have the cooperation mechanism. They live in a group. Ants always live in a group. We humans live in a group. Still being middle of this peak of the pandemic in India, we are able to share the information with each other. We are upgrading ourselves in the terms of the knowledge. Instead of saving life, we are even upgrading ourselves even middle of this pandemic, because of all sharing of the knowledge with each other, because somebody has developed this online communication system. Somebody has organized this event, thanks to Kusum, right? And somebody is giving the lecture, somebody is attending the lectures, right? So and somebody has funded the lecture. The government has funded the lecture. So this is the collective effort that this knowledge sharing is possible. Knowledge sharing is possible. So any creature who who do the collective efforts become intelligent, right? So it's a collective intelligence. It is the emergent intelligence, and it is always among a group of simple agents, right? Third thing is, it is among a group. It is among a group means this collective intelligence or this emergent intelligence cannot be obtained in one or two individuals. For this intelligence, you need a sufficiently large group. Now, what is the definition of this sufficiently large group? Actually, there is no specific criteria. There is no specific number by which I can tell you that this should be the swarm size. This should be the size of the group. Only then the swarm intelligence will emerge. Then the swarm intelligence will emerge. There is no specific size, but usually based on the experience, it is said that if you have the swarm size which is greater than or equal to 30, works very good. works very good for most of the problems. 30 or more swarm size works good. However, the swarm intelligence can also be obtained if your swarm size is 10 or greater than 10. Through some experiments, I obtained that not efficiently, your problem cannot be efficiently solved with 10 members, but some kind of swarm intelligence is emerged. But if your size is less than 10, please don't take these words like if it is 9. Even sometime you can obtain in 9, because these are all are random search based algorithms, right? But if it is sufficiently small, for example 5 or 4, then you may not obtain the swarm intelligence, right? So to obtain the swarm intelligence, you should have a sufficiently large group, and this is for in the field of swarm intelligence. Actually, this is a matter of research concern, that what should be the minimum swarm size so that the computational efforts can be minimized. Of course, you have more swarm size, you have to do more computation. Your system has to work more. You need more computationally efficient device. You need better machine. If your swarm size is less, inferior machine can work. So this is always a matter of concern, that what should be the minimum swarm size of, for example, drones. If you want to make a drone swarm, then definitely you need to study that what should be the minimum number of the agents in this swarm, so that we can perform that particular task, because drones cost a lot. These are the hardwares which cost a lot, and therefore the number of drones, number of agents in the swarm is always a matter of concern, and we the researchers always try to minimize this number, so that the same problem can be solved with same efficiency with minimum possible number of agents in the swarm, right? So this is the definition. So any intelligence which is obtained through collective efforts and which is emerged among a group, then that intelligence is known as the swarm intelligence. I already told you that this is the cooperative, based on the collective cooperation among each other. If suppose we are competing with each other, then also sometimes what is the swarm? Swarm is a group of similar kind of individuals is the swarm. So swarm, you may consider it's a group, right? When large group, then it is just locust swarm. You must have this. Swarm is now a very common term, even to the layman. Just few days before in the news it was locust. However, locust swarm is still in India, in many parts of India, but actually on news these days is Sushant and Ria are there. That's why we could not understand. But locust swarm is you must have heard. So swarm is a group of similar kind of individuals. So when the intelligence is emerged through cooperation among a member of the swarm, then whatever is the intelligence emerged is known as the swarm intelligence. Now let me tell you, just please don't get confused that the intelligence can be emerged only with the cooperation. It cannot be emerged through competition. Yes, intelligence can also be obtained through competition among a group. For example, suppose there is a class of students and there is an exam. If you will not give the competition to the students, suppose you will not give the exams, there is no fear for the exam. Students may not study. A student may not study that with that efficiency, in which efficiency they can. Are you getting my point? That competition sometimes make individuals intelligent, right? So competition is also there, but the algorithms which are in the category of swarm intelligence are not based on the competition. They are based on the cooperation. The algorithms which are based on the competition among individuals are known as the evolutionary computation, which is another category of computational intelligence. This I already mentioned here. This is evolutionary computation. So genetic algorithms are there in which the intelligence is emerged through competition among the individuals. So this is also the basic difference in evolutionary computation algorithm and the swarm intelligence based algorithm. In evolutionary algorithms, the intelligence is emerged. The agents become better through competition with each other, right? While in swarm intelligence, the agents become better by cooperation with each other, right? So cooperation versus competition. This is the difference in swarm intelligence and evolutionary computation. So I hope I have explained you about the swarm intelligence, the basic definition of swarm intelligence. And you can see the example of the swarm intelligence among the in the nature. Mm, Group foraging, thank you so much for good words. I hope everybody should also give the same efforts. This is the cooperation. This is again a cooperation. We need the cooperation. You also give equal attention on my words, and please try to be as much interactive as possible. And I assure you that you will get at least some knowledge after this. So. You can see group foraging of social insects like ants, cooperative transportation. Ants can carry any object which is even heavier than those, right? So division of labor is the one necessary condition for the swarm intelligence. Division of labor says actually that suppose this is the path and here is the some object and ants are here. Some ants are here. Then some ants works from here. Some ants works from here. Some ants works from here, some ants works from here. No ants will sit on the object, right? Because they understand that this will unnecessarily increase the weight of the object, and therefore, this ant is offering its ability. This ant is offering its ability independently, and all these are cooperating with each other, and they are carrying the object in this side. So this is called the division of labor. Another important property is the characteristic of this swarm is the homogeneity. Individuals are homogeneous. I want to say that in the group, swarm can be made of locusts only, ants only, birds only, monkeys only, right? You cannot make a swarm in which ants are there, monkeys are there. Ants and monkeys cannot make a swarm, because what will happen? Then the cooperation may not happen. Actually, suppose ants has its nest here, the food source is here, and they want to go here, right? By finding the minimum shortest path, and there is a nest in which many ants are there, and a monkey is there. Suppose a monkey is there, right? This is the monkey. Now this monkey will say that I will not cooperate with you people, because this food source is directly visible to me. I know that what is the minimum path, what is the shortest path from this nest to the food source, what is the shortest path. I can directly go there. I don't need your cooperation. But since ants are very small creatures, they cannot see the food source directly, and therefore they cooperate with each other. To find the shortest path, and therefore the cooperation may not emerge. We may not cooperate with each other. For example, a Nobel Prize winner, suppose a physicist there who is a Nobel Prize winner, and he may not attend a lecture from a school teacher of physics. May not attend. He may think that I know already all these things what the school teacher of physics knows, and therefore I will not attend his lecture. And since I'm not going to get some information with this school teacher, so I will also not give the lecture to this school teacher. Maybe just if the difference is too much. If the difference is too much, then their cooperation may not be there, and therefore this is a necessary condition that the individuals are homogeneous. And of course, I already mentioned that it should be many individuals in the group. 2, 3, or 4, 5 individuals may not work. Self-organization is another necessary condition. Let me tell you, necessary and sufficient condition. This self-organization plus there is another condition, division of labor. Self-organization and division of labor is the necessary and sufficient condition for the swarm intelligence. Let me tell you about that. Self-organization plus division of labor implies the swarm intelligence, and if the swarm intelligence is there, then definitely these two conditions will be there. So self-organization and division of labor are the necessary and sufficient condition for swarm intelligence. Means, or there should not be any central control. Self-organization means no central control. Means all the individuals are organized in itself without any dictator. all are equal, all can share the information with each other without any central control. And then the swarm intelligence which will emerge. Okay, so I already mentioned these two conditions. What do we mean by self-organization? Self-organization can be obtained by following these four conditions, right? For any algorithm, you need to follow these conditions. Can I take just a second? Hello. सर मैं लेक्चर में हूँ, कौन बोल रहा हूँ? नहीं आप मैं बात कर सकता हूँ, एक मिनट. Sorry people, please just hold on, there is some emergency, I need to talk. हाँ जी अंकल बताइए प्लीज. Sorry, I'm really sorry. Actually, one of my relative got corona positive and he's very serious in the hospital. So, okay. Um, I was talking about the self-organization. I hope you can listen me. Can anybody confirm?
Yes, sir. Audible.
Okay. Okay. So the self-organization can be obtained. The self-organization means the cooperation among the individuals can be obtained through these four properties. Positive feedback. Positive feedback means whenever in the group one individual give some information to other, this individual should respect this information, should consider this information. So suppose I am giving some definition to you people, we all are cooperating, so I am giving a definition of swarm intelligence. Suppose I am giving some definition of swarm intelligence which is created by me, suppose created by me, then since we all are in the equal swarm, in one swarm, so you should consider this information, that whatever Jagdish Bansal is saying is the good definition, correct definition, right? This is the called positive feedback. There is another thing, that is negative feedback. Negative feedback says that whenever this individual says any information to this, it should not be blindly followed. Means whenever I give any definition to you of swarm intelligence, then you should analyze this information. You should analyze this information based on your own knowledge. Okay, the swarm intelligence which I read somewhere else, he was defining this swarm intelligence in this way, but this man is defining swarm intelligence in some other way. It is contradictory. Then you can say that I will not accept your definition, right? What I want to say, that if you will blindly follow any individual member of the swarm, then the swarm can lead to a wrong direction, and therefore the negative feedback is also there. So positive feedback is there, negative feedback is there. Both are to be maintained simultaneously. And let me tell you, this is the one most significant challenge for the researchers in the field of swarm intelligence, how to manage both. Means when to accept the information and when not to accept the information. Analyzing this analysis is very important, right? So positive feedback and negative feedback both are to be maintained simultaneously. If we will not consider anything, then definitely our swarm will not converge. If we will not consider the positive feedback, the swarm will not convert. Swarm will not be able to do anything. Negative feedback means you are not getting me, I'm not getting you, you are not following me, I'm not following you, we all are doing our work. It is called zero positive feedback. All negative, negative, right? And all positive means whatever you said, it is correct, always correct. Like Netaj said, that whatever the leader of the party says is always correct. That's a positive feedback, and no negative feedback. Uh, not to comment anybody, but just in Congress, like whatever the leader says is always correct, positive, positive. Nobody is suggesting no negative feedback. Then of course it can converge to a wrong point, suboptimal solution. The party can go to a wrong direction. Are you getting my point? If you don't have the negative feedback, it can converge to a wrong direction, right? So you need to maintain both the positive feedback and negative feedback to have a good algorithm. Then the fluctuation, the random search means apart from whatever the knowledge you have, whatever the knowledge I have, we both, apart from knowledge sharing, we also need to share some knowledge left, right. Whatever the knowledge is left, right, we also need to search that also. It means whenever one individual gives the information to another, we need not to, even if we are giving the positive feedback, we should give some random component here. Means we need to search nearby locations also. Means if I'm defining the swarm intelligence, if I'm explaining PSO, then you should understand some other algorithms also. So left, right, some gain more knowledge also, fluctuations. So randomness is the integral part. Multiple interactions. Multiple interaction is another important thing, that if I'm communicating with you, you are communicating with me only, and you suppose 50 people are there, then these 50 people are not communicating with each other, then it will not be a swarm intelligence. It will not be a swarm intelligence. It is a central control or a leader based approach, right? Means whatever the information you are giving to me, and I am spreading this knowledge to everybody, and then this is a some node based algorithm. And if this node is failed, if this node is not performing good, suppose I'm not performing good, then the swarm cannot work good. Then the swarm cannot work good. I hope you are getting my point. And therefore, if one individual or two individuals are not working good, then even the swarm can work good if all are interacting with each other. For example, suppose these 4 members, 5 members are there, then they are communicating with each other directly, or this type of communication is there, so that everybody is aware of everybody. So it is a multiple interactions. Division of labor, I already mentioned about that. That if there is an object, they different abilities the individuals can offer to complete the task. Now, why the swarm intelligence for optimization? Now I'm coming to the swarm intelligence, particularly for application part. Then it is a if you have a continuous optimization problem which can be non-differentiable. I told you about this x1 equal to x0 plus h, where your h can be minus f x0 by f dash x0 in Newton-Raphson method. I'm talking about Newton-Raphson method. So in this Newton-Raphson method, if this function is not differentiable, then this Newton-Raphson method is not applicable, right? This Newton-Raphson method is not applicable if the function is not differentiable. So what to do? In that case, PSO kind of algorithms are applicable. So non-differentiable, non-convex, highly nonlinear, have many local optima. Then these kind of problems are actually very difficult problems. And let me tell you, almost all kind of real world problems are of this kind. Non-differentiable, non-convex. They only satisfy the mathematical properties, and therefore for these kind of problems, PSO is a good choice, or swarm intelligence is a good choice. There is another category, the discrete optimization problems. In discrete optimization problems, actually what happens, the problem may be the NP complete problem. NP complete means non-polynomial time, means in you cannot find the solution in less than the exhaustive search time. Means suppose the exhaustive search to solve a problem takes, suppose t time. T time is taken by the exhaustive search. This is the exhaustive search which is taking t time. then the time taken by any other algorithm, is suppose T1, then T1 is not less than T. If T1 is not less than T, then the algorithm is known as the NP complete problem. The problem is known as the NP complete problem. So for NP complete problem, for example, the knapsack problem, traveling salesman problem, cargo loading problem, paper cutting problem, all these kind of problems are NP complete problems. And for those kind of problems, these swarm intelligence algorithms are really very good. And of course, to have better search speed, we use these kind of algorithms. And the research is huge. You can introduce new swarm intelligence algorithm, you can hybridize, you can modify, or you can apply. So these are the 4 areas where we can do our research in the field of swarm intelligence algorithms. There are many swarm intelligence algorithms available. Thousands of the swarm intelligence algorithms are available. And yes, PSO can be used for differentiable problems also. Of course, PSO is a general algorithm. PSO is a meta-heuristic algorithm, not a heuristic. It's a meta-heuristic algorithm which can be applied to non-differentiable as well as differentiable problems also. But let me tell you, the logic is very simple. Jahan kaam aave soi kaha kare tadwar, right? It's a waste of using the sword where the task can be obtained by just a knife. If something can be done with a knife, why to use the sword? So actually, if the function is differentiable in mathematics, we have a very rich literature in mathematics which can solve the problem if the function is differentiable. So there is no need of the particle swarm optimization. Also, the particle swarm optimization can be applied to non-differentiable problems. This doesn't mean that if you know the PSO, no need to study the mathematical algorithms. Actually, mathematical algorithms always gives the correct answer. They are the deterministic algorithms. While there is a problem with these algorithms that they are stochastic algorithms, probabilistic algorithms, they give the answer in probabilistic manner, means the answers obtained by PSO or other swarm intelligence algorithm need not to be the correct always. They are always giving near optimal solution, while the deterministic algorithms always gives you the optimal solution, true optima they give, and they give the near optima. And therefore, if your function is differentiable, if some mathematical algorithm can be applied, application of swarm intelligence based algorithms or other evolutionary algorithms is never recommended, because here you cannot be able to get the guarantee that this is the final answer, while in the mathematical methods you can always give the guarantee of the correctness. So here let me just tell you that thousands of the swarm intelligence based algorithms are there. Every day hundreds of the algorithms are proposed in the category of computational intelligence. Of course, every month people are proposing the swarm intelligence algorithms also, but not all are becoming popular. The particle swarm optimization algorithm was the first one which became very popular. It was introduced in 1995, which became very popular. Ant colony optimization is another algorithm which was introduced by one Italian scientist, Marco Dorigo. And artificial bee colony algorithm is another swarm intelligence algorithm which is quite popular. In 2008 it was introduced. And spider monkey optimization is the algorithm which we introduced in 2014. In 2014 which we introduced with two of my students, my PhD students, who are now faculty, well established faculty now, Dr. Harish Sharma, Dr. Simpi Singh Jalan, and one of our research collaborator who have one very significant work in particle swarm optimization, Mr. Maurice Clark. So Maurice Clark is one French scientist who worked significant in PSO. So we four people worked in 2014 on this algorithm, and we introduced this algorithm in 2014. And let me tell you, I think this algorithm's lecture is also proposed somewhere during the schedule, and Dr. Harish Sharma, I think, will take this algorithm. Okay, just before I forget, before I move, there was a question that what is the application? So let me tell you, just quickly I tell you, there is a report there is an industry report. Every year the industry reports comes. So there is an industry report. According to that industry report, World Industry Report, CAGR, compound annual growth rate of swarm intelligence, is increasing by 28.5 or 28.7. I just get confused, but around 28% in next 5 years. 5 years. In next 5 years, it is growing with this rate, and in next 10 years, it is growing with more 37 point something. In next 10 years, the swarm intelligence industry is increasing. This is the increment rate of the swarm intelligence increase rate. For in any industry, the growth rate, this growth rate is really very significant. So now you can understand how the swarm intelligence is important in the current time. This industry is getting one of the top growth rate in the any industry, any latest technology which is introduced into the industry. And there is another statement in the report that in the swarm intelligence, particle swarm optimization and ant colony optimization, it is making 80% share. Swarm intelligence industry, in the swarm intelligence industry, 80% share is because of PSO and ACO. PSO and ACO are so popular, so important, so applied that they are making 80% share in the swarm intelligence industry. And all this application area, there was a question that where it is applied. In the drones, in the most of the applications are in the drones and the robots. In the industry robots, for example, you must have heard about this Amazon delivery drones. So they are doing they have all, of course, implemented individual single drone, Amazon delivery drone. Now they are introducing the swarm of drones, swarm of Amazon delivery drones, right? Means if I ordered, suppose 10 kg any material, and that single drone cannot carry 10 kg, and the limit is not 10 kg, right? And then they can send 2-3 drones simultaneously to carry that 10 kilogram weight to me, right? So drone, they communicate with each other. A group, suppose 50 drones, they started flying, and then they make consensus, they go somewhere, deliver. So all this industry is based on this ant colony optimization and PSO. This doesn't mean that all other algorithms are not important. All the algorithms are important. Let me tell you, all the algorithms are important. Actually, these two algorithms were initial algorithms. In 1995 it was introduced, and in 1993 this was introduced, right? So these are the most oldest algorithms in the swarm intelligence, and therefore most old algorithm. That's why these algorithms become popular in the industry, and there are better algorithms available. Someday spider monkey optimization algorithm will also make a significant part of the industry. So it takes time to become the part of industry, right? So let me tell you, everywhere the application is there. Now it is up to us. It is up to us that how we will make these applications more viable for our problem. How to model, how we can model our problem so that it can be solved using swarm intelligence. Let me come quickly on PSO now. PSO is inspired by the now I'm starting the PSO. I'm already in 1 hour and 15 minutes already passed. So particle swarm optimization is inspired by the fish schooling or the birds flocking behavior. How the fish behave, fish swim together, or how the birds fly together. So this is the basic inspiration behind the particle swarm optimization. And let me tell you that birds flocking has these four properties. Safe wandering, they do the safe wandering. They do not collide with each other. Dispersion, they maintain some minimum inter-agent distance, like this distance is maintained, this distance is maintained, this distance is maintained. Aggregation, they also maintain the maximum distance. Suppose there is a group, and here they also maintain, this is the maximum distance. So this is called the aggregation. This is called the aggregation. Just a second. Okay. The maximum distance. So this is called the aggregation. They also maintain the maximum interagent distance, minimum interagent distance they always maintain. Another thing is the homing. This is the one most important property, that why they are swarming, why I'm giving lecture, why you are attending lecture, why the birds fly together, why the fish swim together. What is the benefit? Why they are not living individually? So that is called the homing property. The objective, any particular objective that is to be followed by all the members. There is certain region, there is a certain region which makes them a group. So that region is called the homing property. That region is called the homing property. And this homing, in our optimization problem, this may be the true solution. Right? Homing means, home means the optimal location, maybe the maybe the home, and the members trying to reach at this home, members trying to reach at this home is known as the homing property. Is known as the homing property. Homing means reaching towards the optimal solution, right? So in the PSO, we are following only these two properties. Out of those 4 properties, we are to follow only these 2 properties, means dispersion and safe wandering. Dispersion and safe wandering, these 2 properties are not considered. Means in our PSO, the 2 members can come closer to each other. No restriction on this. And even they can superimpose to each other. They can come superimpose to each other, means they can collide also, right? So safe wandering is not considered, dispersion is not considered, only the homing and aggregation is considered. And based on this, there are certain 5 basic principles for PSO. I'm not considering right now for these. And coming to the PSO itself, it is developed by 2 US scientists, James Kennedy and Russell Everhart, in 1995. This is me, right? I was lucky enough to meet these 2 great scientists in 2008 when I was in US on one IEEE fellowship for short visit on IEEE fellowship. That time I met these 2 people. Okay. So let me just come to the PSO implementation. PSO uses a population of individuals. I already told you that all the swarm intelligence based algorithms always uses a population or a swarm. This population is a swarm. So population of individuals to search the feasible region of the function space. So, and this population is known as the swarm, and every individual in this swarm, means in the locus swarm, the locus is known as the particle. So we will call it particle. We will call it particle. Can you just hold on just one? Sorry, actually in other room my son was doing some activity, so lot of noise. Schools are also going parallel, parents, kids all are attending. Okay, so here is the this individual is known as the particle. Individual is known as the particle, and this group is known as the swarm. Okay, so this is the terminology. What can be the real life application? So this Amazon delivery drone is the one real life application. Real life application means, for example, let me tell you that I applied the problems where I applied the swarm intelligence or PSO or ACO or these kind of algorithms. So the drones, I'm developing some drone algorithms and it is being applied. Another is the one wind farm optimization. I published few papers also on this, that in a given wind farm, suppose this is your wind farm, then where should be the wind turbines situated so that the annual energy output of the entire wind farm is maximum, right? So to find the optimal locations of the wind turbines, this is the one problem, right? For this problem I applied. I also applied this to the knapsack problem. Knapsack problem, I hope you understand that this problem can be modeled. This problem can be applied to the cargo loading problem. Knapsack problem has applications in so many. Traveling salesman problem that can be solved using this. To find the minimal spanning tree problem, you can apply these kind of algorithms. So actually this is all up to us, that where we want to use it. There is no area of application which is right now um, uh, separate from this swarm intelligence. So here let me start with the particle swarm optimization algorithm now. So in the particle swarm optimization, I told you that if you remember, here is the agent. If you remember the general framework, here is the agent, then it will take some action and will encounter with some environment and then will learn, right? This is the way how the agents to be learned. Now here the agent in our algorithm, the agent is these particles. Agents are these particles and we need to make them intelligent. Now next around 20 minutes are very important to understand this particle swarm optimization algorithm, and I assure you that if you will listen carefully with full attention, you will be able to understand PSO today completely. I assure you this, right? Just concentrate on this, and theoretically also you will, not only the implementation part, but the theoretically also you can understand. So what I want to say, these are the individuals which we want to make intelligent, right? So these particles are the intelligent, are the agents which we want to make intelligent. So how to make intelligent? Need to take some actions. So suppose this is denoted by x1, this is denoted by x2. So this x1 will take some action, and I told you that this x1 dash, after action it will become x1 dash, and this is your x1, and the action is this. This is your action, right? Now this action h, like I told you in Newton-Raphson method, this action is this, right? In Newton-Raphson method, this is the action, but here in PSO, the new position equal to the current position plus h. Here is the action. Now this action is defined in PSO, this action h is defined in this way. If you will attend the, I will explain the ant colony optimization algorithm also in the last lecture. In the next lecture, I have one more lecture, so there I will explain the ACO. So if you will attend ACO, this action is different. If you attend the spider monkey optimization, then you will realize that this action is different. When you will study genetic algorithm, the action is different. When you will study ABC, the action is different. So these actions are different. The definition of this action H is different according to the algorithm, varies according to algorithm, and accordingly the efficiency varies. So how to define this H in case of PSO? So in case of PSO, this H is dependent upon these two factors. This is your H, this is your H, and it depends upon these two factors. One is the persistence and one is the social influence. Just consider this. I told you, if you remember, the negative feedback and positive feedback. If you remember, I told you about the negative feedback and positive feedback. Means whenever anybody is giving me some information, suppose this is x1, if x2 is giving me some information, I should consider it and I should not follow blindly it, right? It means when I'm considering this application, I call it social influence. I'm influenced from the society. I'm influenced from the others. It is called social influence. If this x1 is influenced by x2, if x1 is following the information given by x2, then it is called as social influence, by social influence. And if this x1 is not following x2, and this x1 is moving, suppose x1 is here and it is moving in this direction based on its own knowledge, own performance, right? Then it is called persistence. He's persist for his own knowledge, cognitive knowledge or cognitive component, right? So cognitive, based on the cognitive knowledge, if he is moving in this side, then it is called negative feedback. Means this x2 is giving this information and he is saying that you move in this direction. The x2's information is that you move in this direction, but he's not giving words to this x2, and he's moving in this direction. It means he's following the negative feedback, right? And sorry, yeah, he's following the negative feedback, and he's not giving any weight to the positive feedback or the society or the social influence, and he's taking decision in itself. Means cognitive knowledge, his own knowledge. Based on his own knowledge, he is taking the decisions, and therefore it is called the persistence. Or this persistence can also be defined as egoistic component. Egoistic component, right? Persistence, egoistic component, or the cognitive component, or the cognition. Based on the cognitive knowledge or the cognition, he's taking the decision. Another is this social influence. If he's going this, now what can happen? Now the obvious question is that I told you that if you will follow the negative feedback only, if you will, there is no difference. Negative feedback and persistence, there is no difference. It's the same thing actually. Persistence means you are not giving any positive feedback to others' knowledge, and you are using just your own knowledge. Means the negative feedback to everybody else information, and you are moving based on your own knowledge. So that is called the persistence. Sorry, I was saying that yeah. Now what happens that suppose this is the individual x1, and its cognitive knowledge says that you move in this direction. Its own knowledge. Suppose this is me, who's my previous experience. My knowledge says that I need to move in this direction, but there is another individual x2 which is giving the information that you move in this direction. Means the direction is this. This is the same angle, I hope. So direction is this. I should move in this direction. This is the information given by the social influence, and this is the information given by persistence, right? Now these are the two different directions. Now which direction to be followed? I told you that we need to maintain the balance between both. So now one obvious simple answer is you follow the middle direction. Right? It says this, you take this. Means you take, suppose this end is x1 dash, and this end is, sorry, x1 double dash. This end is x1 double dash, and this end is x1 dash. So this vector is your, I hope you understand that this x1 dash, I don't know, this becomes slow. X1 dash, this is the one vector. I hope you can understand that I can write this vector as x1 dash vector minus x1. Oh, it is being slow. Sorry, just x1 dash minus x1. I hope you know that this vector can be written as this. How you write AB vector? How you write AB vector? As OB minus OA. So similarly, I'm writing like this. OB minus OA. So similarly, I'm writing x1 dash equal to x1 dash minus x1. So this is the one vector, this vector, and this vector can be represented as x1 double dash vector equal to x1 double dash minus x1. This is the vector, right? So these are the two vectors, and this middle means Just add these two vectors, x1, x1 double dash vector plus x1 and x1 dash vector. This is the addition, vector addition, simple. This is the resulting vector of the addition of the two vectors, right? Now this is the middle one. But simultaneously, if you remember, apart from this, means now he's taking care of the positive feedback and negative feedback both. I hope you remember now. Positive feedback and negative feedback both are taken care of when I'm taking this middle path. But simultaneously, if you remember, I also mentioned about the third property, which is called the fluctuation. थोड़ा दाएं बाएं देख लेते हैं. Just look around left, right? Means explore something left, right. If you will follow this, it means you are not following the right fluctuation property. If you will follow this, you are not following the fluctuation property, and therefore to insert this fluctuation property, what happens? Instead of just adding these two vectors, we give some random weights to these two vectors, some random weights to these two vectors, phi1 and phi2. Now, what are these vectors? This is again a challenge. I'm coming to those, what should be those weights. I'm coming to the next slide. But now I hope you understand that how the positions are modified, how the members in the swarm in PSO are moving from one point to another point. This is the way. This is the way how they are moving. This is the calculation of H actually. This is the calculation of H. This is the change. This is the H. This is the step size, or this may be, you may call the impact of movement. Okay. So this is the I think because of this, I don't know why the equations are not here. No equation is here. I think it is gone because of this PDF. I made the PDF of PPT and I made in Mac, and I'm using this. This Surface is Windows system, so I think there's a problem. Okay, let me write it by myself. Okay, so just let me write it myself now. Actually, what happens in PSO, in order to apply this concept, of new position equal to current position plus persistence plus social influence, we will use two equations to implement this concept. And the two equations are, one is the velocity update equation, another is the position update equation. So positions are updated using these two equations: velocity update equation, position update equation. In the velocity update equation, we calculate this H. And instead of calling now it H, we will call it V, because we are defining this modification with the change as V. We are defining this as the velocity. We are calling this H as the velocity, right? We are calling this H as the velocity. So this velocity, the new velocity, equal to the old velocity. This is the velocity update equation. Plus, I told you that this H depends upon two informations: persistence and social influence. So this V is modified. Using two things: persistence and social influence. Persistence means the current position. Sorry. Okay, let me first write the xg, not xg, xp vector plus, I'm just deliberately I'm leaving some space, xg vector. I hope now you understand that this is the vector's own cognitive knowledge. Actually, what happens, suppose this is the position, then this is the direction of xp. This is your x, and this is the direction of xp. Xp is the particle's own best, whatever the best knowledge I have, that is this direction, xp. So particle's own best position. This particle has earlier visited some places, and he knew that what is my best position, or what is my best direction. So that is this direction. Now xg is the g best. This is called the p best. This xp is known as the p best, and this xg is known as the g best. So this xg is the global best. the best solution of the entire swarm, best direction of the entire swarm. So this is suppose this direction. This is suppose this direction. So this is your XG direction. Now I hope you understand that the addition of this, he's coming from some this direction, right? So this XG, if you will add these two, it will give you the resulting vector, which is in just middle of this. But I told you that fluctuation should be there, and therefore I'm giving some weights to these two vectors, right? So phi1 is the weight which I'm giving to this, phi2 is the weight which I'm giving to this. Now how to calculate this phi1 and phi2? Let me rewrite this equation in this way, that V plus phi1 is your C1R1. Now what is this C1R1? Just I'm coming. Let me just complete this writing. And XPX, I hope you understand that I can write like this. This is the vector, AB vector. So OB minus OA, XP minus X, plus phi2 is your C2R2. And this I can write XG minus X. I hope now you can understand. Actually, what happens, you have calculated this new V equal to the old V. Initially, we start with the random V's. Initially, we take the random. Similarly, like random positions, we will take the random velocity also. And these are the two terms. One first term is the cognitive persistence, and this another term is this social influence. Persistence and social influence we have calculated. And both the terms, since I told you that negative feedback or the persistence and the social influence or the positive feedback, we have to maintain the both. We have to maintain the both, and therefore we have incorporated both terms here, both terms simultaneously with different weights. Now, you know, there is a question that how much weight I should give to others' knowledge and how much weight I should give to my own weight, my own knowledge. So suppose I'm giving more weight to the social influence, it means I'm less confident. When if I will always follow others' word, then what you will say me about me, that he has no confidence in itself and he always follow others, right? So means no confidence. No ego means no confidence also sometimes, right? So if I will give more weight to others' information, if this weight phi2 is more than phi1, if phi2 is greater than phi1, then it is more influenced by others. So suppose Professor Bajpayee telling me that you give the lecture on PSO, and Professor Sripati Budhi giving me that you give the lecture on ABC. Just imagine that. Then as soon as Professor Bajpayee told me PSO, I started PSO. As soon as Professor Budhi told me that you start ABC, ACO, then I started ACO or ABC. Are you getting my point? I just changed my topic. Then what will be the ultimate goal? Ultimate goal will not be fulfilled. If I'm just following others, then my behavior will be almost like a random behavior. My behavior will almost be like a random behavior, and therefore I cannot give more weight to the social influence than the cognitive component. Now just think opposite. I can give more weight to my own knowledge as compared to others' knowledge, means I'm giving more, means the egoistic component is higher than the social component, is higher than the social component. I'm giving more weight to my own knowledge as compared to others, means I'm not listening to others. You all want that you speak on PSO, but I'm speaking on ABC, right? Then you may not be benefited, then it may not be benefited, and I may go in the wrong direction. It may not be beneficial for the benefit of the swarm, right? So egoistic component also I cannot take larger than social weight, and therefore what I say that the both weights are actually equal. Both weights are given actually equal. Now just imagine if I will give more weight. Now another problem. If I will give both weight equal, then what will happen? The resulting vector will always be the middle vector. Then there is no fluctuation. Then there is no fluctuation means I'm not following the third property. If I'll give more equal weights, then the fluctuation property is not satisfied. I will always go in the middle of both, right? That is also not possible, means I may not explore the search space. And therefore, what is the recommended solution for this? That instead of giving the equal weights, give them the random weights. That random weights means sometimes it may be more inclined towards this, and sometimes it may be more inclined towards G best, and sometimes it can be more inclined towards this. So, and sometimes it may be equal also. So it may be uh, it may be in the same way also. Sorry, just let me just clear this so that I can better write. So here equal weights, I'm giving this equal weights. So what I'm saying that phi 1, phi 2 are equal, but phi 1 is a random number. Phi 1 is a random number, and this random number is actually a random number between, this is a random number between 0 and C1. And what is that random number? Now I say that the random components, random weight should be given. What should be that random number? So random number is C1. That any random number between 0 and C1 I will give, and phi 2 is a random number between 0 and C2. And now this C1 and C2 should be same, should be equal. Ideally they should be equal, but of course according to the problem we can modify them. That's why right now I'm taking C1 and C2 different, but most of the time C1, C2 are equal. Most of the time C1, C2 are equal. So now you see that I'm giving equal opportunity. I'm taking a random number between 0 and C1, and I'm again taking a random number, another random number between 0 and C1. It means I'm both the time I'm giving equal opportunity for that random number. Now, since it is a random number, and therefore it is not necessary that the number, suppose a random number this and this. So these T1 and T2 may not be necessarily same. However, the range is same, but the T1, T2 may not be necessarily same. It means one way I'm giving equal opportunity to the social influence, to the persistence, and one way I'm taking the fluctuation also. Means sometimes it may be more inclined towards persistence, and sometimes it may be more inclined towards social influence. So that keeps on varying. So T1, T2. The number may be T1, T2. So now you can understand, I hope, it's simple mathematics. It's a simple mathematics that if I write that phi 1 equal to a random number between 0 and C1, then I can write it like C1 into a random number between 0 and 1. I can write like this. So if I'm writing a C1 into a random number between 0 and 1, can I write like C1 into R1? So R1 is a random number between 0 and 1. So here you can see now the weight is C1 R1. It is a random number between 0 and C1. It is a random number between 0 and C2. So I have given the different weights. So this is your velocity update equation of PSO. Now after obtaining this V, just the second equation is your position update equation, and this position update equation is nothing but a change in X. New position equal to old position plus this V. So new position equal to old position plus this V, whatever we have obtained from previous equation, velocity update equation. So these are the two only update equations in PSO. If we have understood this philosophy of developing these equations, means we have understood the PSO philosophy. Okay, so this I have already explained. So right now I'm not explaining this, what should be the value of C1, C2. So I already explained you that this is now the algorithm of PSO. How the algorithm works. So instead of explaining this, let me write by myself, right? Let me write the algorithm by myself, and let me find out some. Okay, this is the only blank slide where I can write. Okay, so here again I'm writing this. Actually in PSO what we do, just after this I can explain you the implementation also of PSO. So let me tell you that in PSO, first of all, first step is initialize. Sorry, let me just take just for better writing, let me take, just a second, give me a minute. Okay. So I'm just making this. So the first step is the initialization process. Initialization process. First step, the initialization means the solution is initialized, random population. Population is generated randomly initially in this search space. Suppose this is your search space, then anywhere we can generate some initial swarm. So nobody knows where the solution is. So randomly generated. Initialization means generate a set of solutions randomly in the given search space. Whatever is the boundary in this search space, you generate the solution randomly, the first step. And then the next step is evaluate. Evaluate means this is your search space. If this is your search space, and suppose this is your true solution, this is the location of true solution, and here are your random solutions. Here are your random solutions. Then the evaluation. Evaluation means you calculate the fitness of each solution. This is the distance in this solution. This is the distance in this solution. So you can say that this solution, suppose this is your x1, this is your x2, then you can say that the fitness of x1 is inferior to the fitness of x2 because x2 is more close to the solution, So calculate the objective function values of these solutions, which we have generated in this initialization, which we have generated here. Calculate the objective function value means their fitnesses. We have to calculate their fitnesses means we have to say that which is a good solution and which is not a good solution. So once we have evaluated them, we can identify. Sorry, we can. ये क्या हुआ? अरे यार, delete हो गया है. Okay, initialize. Initialize, evaluate. After evaluation, what we can do, we can identify the G-best, P-best, G-best and P-best. G-best for the best solution of the swarm, P-best of your own best position. So currently in this initial case, actually P-best is equal to the current position also, because every individual has no previous experience. This is your agent, it is taking some action, it is going to take some action, right? So here this agent since has no previous experience, so it's P-best and the current position both are same. It's P-best and the current position both are same. Okay, and identify the G-best and P-best. Now apply the velocity update equation. Can I write just VUE? Is it okay? Velocity update equation. Apply the velocity update equation and obtain new velocity. New velocity means V. Obtain new velocity, and then apply the position update equation. PUE, position update equation. Now put this V into this position update equation, and I hope you remember this velocity update equation. V equal to V plus C1 R1 and P best minus X plus C2 R2 and G best minus X, and this is your position update equation. X equal to X plus V. This is your position update equation. So you will put this obtained V into this equation. Actually, just quickly I tell you that here this equation looks like against of the physics rules, that velocity is added to the position. Velocity means the rate of change in the position. Actually, this V is a rate of change in the position, right? And velocity means the rate of change in the position with respect to time. So here the time is the iteration. So here this velocity is calculated. It is a change in the position. It is the rate of change in the position with respect to iteration. And iteration counter is incremented by 1. So actually here the delta t is always 1. And therefore the dimension of x is L and the dimension of V, which is your LT minus 1. You remember? the dimension of this V is LT minus 1. Since T is 1, so dimension of V is also L. And now we can add X and V. So this is actually not against the physics rules. It is okay. Apply the position update equation. Then after updating this position, calculate the, means go to step 2. Go to step 2 means calculate the, again, objective function value and identify the G best and P best. And now if you are here, sorry, here let me put another step, that termination criteria. If you are happy with this G best, you stop here, otherwise keep on iterating this equation, this algorithm. So in this way you can obtain, ultimately your G best will be the optimal solution. Ultimately your G best will be the optimal solution. And let me tell you that this PSO, this equation, this algorithm is one of the most simple algorithm in this case. And so compare units of X and V. X and V is, I already told you that V is the change in X. V is the change in X. So the unit of V is also the unit of X. Now X may be anything according to your problem. This X may be the position of a turbine. This X may be the amount which is to be optimized from an industry. Suppose the Mukesh Ambani wants to maximize his profit from the industries, then this X may be the profit. Whatever, according to your problem, this decision variable may be anything, right? And that is the unit. If it is profit, then the unit is in rupees. If it is location, then it is a coordinates. And if it is amount of some water or something which should be flown minimum during the flood, then it may be in gallon or something. Depends upon whatever the problem you are considering, right? Okay. So that's the algorithm that I have explained. I still have 5-7 minutes, so can I just quickly take Kusum? Can I take just quickly the example of PSO, a numerical example of PSO, so that you can understand the practical implementation of PSO. Is it okay, Kusum? I take 5-7. Okay, my time is up to 12, so 6 minutes authentically I have. So let me utilize those quickly. Suppose you want to solve this problem. Suppose you want to solve this problem, x1 square plus x2 square. You want to minimize this in this range. So your search space is your -5 to 5. This is your search space, right? -5 to 5. So this is your search space. So what you will do initially, you will generate some random solutions. So these are the random solutions. This is your first location, whatever, suppose this location, then this is location, and so on. So you will generate some random solutions initially, and then, sorry, and then, just a second, I will use mouse now. I'll take questions also. No worries. So we will generate velocity also randomly, and then let me just quickly finish this. Calculate the fitness. This is your objective function values, and this fourth one is the best solution. And then you can see here, we will update the equation, the component-wise update. So this is your velocity update equation. So here we will put the first randomly generated velocity. C1 is a constant, which is 2. R1 is a random number between 0 and 1. P best is the best position of the swarm, which is the current position also. So both are same in this case. C2 is again 2, constant. R2 is a random number between 0 and 1. G best is the best solution of the swarm. So here you can see the fourth solution is the best solution. Fourth solution is the best solution, and its first component is 1.64. So here I will write 1.64, and then this is the current position. And then we will obtain this V, we will add this V to the current position, we get the updated X. So this process will be applied to all the positions and all the components. So this component, first component, and then the same is for X12, and then for X22, X2122, for all the particles we will do, and we will get this updated swarm. And here you can see, again we will calculate the Yeah, I will share the example, no worries. You can see here now the first solution becomes the best solution. Now this is the minimum value. So first solution is the best solution, and we'll keep on doing this. Now the best, P best, we need to check that which is the P best. Now since it has the previous experience also, so if the previous solution is a better solution, then the P best will be that and the current solution is different. So this process continues till end, and that's all from my side. Okay, let me take the questions. Now I'm ready for the questions. If you have questions, I will, of course, no worries. Not to say that I will share the slides and the example both. No worries for that, right? And even if you have other questions, you can write to me on my email also. Okay, now I'm open for the questions.
So in some cases, it happens that the swarm intelligence algorithm converges at fifth or sixth iteration. Then in that case, won't we call that a computational intelligence algorithm?
So if your algorithm is converging in fifth or sixth iteration, just in 5 or 6 iteration, it means your problem is not difficult. It is a computational intelligence algorithm, of course, but your problem is not so difficult that your swarm intelligence or computational intelligence algorithm is required to be applied. Let me tell you, if any problem is giving, the solution, it means any problem solution is obtained in just 5-7 iterations or up to 10 iterations, 20 iterations even, then it is not required to be used for swarm intelligence. You can even do it by hand also, or some other deterministic methods, or some simple exhaustive search can also work. No need to go with the swarm intelligence if just in 5, 6, 7 iterations you are getting it. Exhaustive search, you do the exhaustive search. Exhaustive search means try all possibilities. You will get the solution, right? So your problem is not sufficiently difficult to be tackled with swarm intelligence. I want to share one experience, my experience in this case. 3 years before, around 3 years before, I was examining a PhD thesis of IIT Bangalore student who had done the work on flood prediction, Bihar Kosi River flood prediction, and he applied swarm intelligence for that flood prediction, and all the results were just obtained in 30 iterations, right? And this was the big question, and the thesis came to me, and of course we cannot do anything because he had worked heavily, but let me tell you, this was a big drawback of the thesis, that if the problem can be solved in just 30 iterations, why to use the swarm intelligence? You can get the same solutions by exhaustive search or some other simplified approaches also, or some heuristic approach also, right? So that is the computational intelligence. Okay, any other question? I can take from the chat also.
Hello. And sir, if
Sripati,
Sripati from Chennai.
Yeah.
So, is there any bound that you have mentioned that if it is 30 iterations, we can go for some other heuristic, deterministic approaches? Is there any bound? In the sense, okay, if it is some 1,000 to 10,000 iterations, we can go for SWAM. Is there any bound?
No, there is no such specific rule. That's a good question. That you need minimum, means the problem can be solved in this much number of iterations, only then you can. No, there is no such rule. Actually, applying, getting the solution in 5-7 iterations is not a bad thing. It is okay, but just I'm saying that if something can be solved using some problem can be solved using a knife, why to use the sword? Right? Means there is no use of swarm intelligence. Means you cannot justify yourself that I'm using swarm intelligence. And anybody will appreciate your efforts if your efforts are significant. If your efforts are difficult, means you are solving a difficult problem, only then efforts are appreciated. If you are solving a very easy problem using swarm intelligence, then people may not appreciate your efforts, and your efforts may not be accepted. So no such bound, but you need to justify that your problem is difficult. It cannot be solved easily, and that's why I'm using the swarm intelligence.
Okay. And as a mathematician, I'm basically applied mathematician.
I'm also a mathematics student.
Sir?
Yeah, I'm also a mathematics student.
Yeah. So since you are saying that if we have a SWOT means we have to use the correct tool for attacking the problem, and we have a prime number theorem. There is a very big question in the number theory.
I'm not getting. Just speak slowly and clearly, please.
Okay. Sorry. So prime number theorem. Prime number theorem given in any number to check whether the number is a prime number, or suppose I have given 1 trillion number. Can we use there? Can we use the SWAM optimization? I mean, to check whether the number is a prime.
As far as I understand, there is no such theorem, prime number theorem. I think you are talking about fundamental theorem of algebra.
No, what I mean is prime number. To check whether a number is prime, if I give 10,000 digits or say 1 million.
Primality checking. Okay, primality testing algorithms. Okay, I got your point. Yes, that's a really a wonderful application, and I wasted my almost a year in this solving this problem. So primality testing algorithm, yes, a really wonderful application. So swarm intelligence can be used. Yes, it can be used, but it is not efficient. Actually, there are many other probabilistic algorithms for primality testing algorithm are available, which are better than the swarm intelligence algorithms, because there is a reason why it is a reason. Because you understand, if you have studied the prime numbers, then you know that the one prime number and then the next prime number, there is no such relation. If x1 is a prime number and x2 is a prime number and x3 is a prime number, then you cannot predict whether the next prime number will come after 10 numbers or 50 numbers, right? And this unpredictable behavior making these prime numbers useful for the cryptography also. You know this, right?
Yes.
Now this is the property which is unpredictable, right? The numbers are probabilistic, numbers are stochastic, while all the swarm intelligence algorithms works based on the experience. All the swarm, this is the basic concept behind the swarm intelligence algorithms. They work on the experience, means heuristic. They are the meta heuristic, means they think that, okay, I was here, if a number is x1 is a prime number and x2 is a prime number, in this, if this is the difference, then the next prime number will be expected at this much difference, right? Yeah. So all the swarm intelligence based algorithms find the new solution based on the previous experience, while in primality testing this previous experience never works, and therefore theoretically swarm intelligence are not efficient for the primality testing algorithms. There are many good algorithms are available.
Okay. Thank you, sir. Thank you a lot.
Thank you. Some other questions? I think somebody else was unmuting. Actually, a lot of questions are here. PSI applied to FIR filters coefficient. Yes, it can be applied anywhere, wherever is the optimization. You can apply the PSO. Yes. And
Sir, if I am solving a problem or if I have a problem and where both evolutionary algorithm and swarm intelligence algorithm can be applied, so in which direction should I proceed? Like which algorithm should I choose?
Again, Soumya Bansal, you asked the $1 million question, and I don't have $1 million, right? So there is no fixed answer. There is no deterministic answer. These are the algorithms which works on the randomness, right? Randomness. So I cannot give you the thumb rule. Of course, I can give you some recommendation based on my experience, but no thumb rule, no mathematically deterministic algorithm. No mathematically say that this algorithm will work better on this problem. All algorithms are equal in performance according to no free lunch theorem. So we cannot designate one algorithm higher than for one, but problem to problem, the algorithm's performance varies. Problem to problem, algorithm's performance varies. If you are working, suppose for wind farm layout optimization problem, one algorithm working good, one algorithm may not work good. And this always comes with the experience. This always comes with the application, applying experiments, right? So I cannot say at this moment that this algorithm is better, but based on the experience, let me tell you that which algorithm should be tried first for which kind of problems. If you have a discrete optimization problem, ant colony optimization algorithm is a good algorithm, let me tell you. For discrete optimization problems, PSO, ABC, SMO may not work good. ACO works good. But if you have a continuous optimization problem, then ACO may not work good. PSO, ABC, or differential evolution is another algorithm that may work good. And let me tell you, somebody on the chat just asked that which algorithm is better, PSO or D? Or D is better. But please don't take again my words. D may be better for some problems, but overall I found that D is very simple, very easy, minimum parameters. You remember in PSO, you have to take two constants, C1, C2. This is a parameter. There is again one parameter in the again latest version of PSO, that is called inertia weight. So inertia weight is another parameter. Three parameters are there which are to be set by the user. While in differential evolution, only one parameter is there, that is the scaling factor, right? So differential evolution I found better, and the performance is also very good overall. But deterministically, I cannot say that always DE will work better than PSO, but most of the time DE works. DE is easy to implement and gives almost equal performance than PSO. Now, another thing is, suppose you want the answers quickly, and you can compromise with some error. You can afford some error, but you want the answer quickly. Then I say that instead of ABC or spider monkey optimization, you go with the PSO or differential evolution. PSO or DE gives quick results, but they can have error. Now, if you want more accuracy but can afford more time, you have more time, but you want to minimize the error, then you go with the ABC or SMO. If you want to further minimize the error and you have further more time, then SMO is a better choice. Spider monkey optimization is a better choice. So this is just general recommendation, and they may not be always true. Remember, but most of the time they are true. When I say that most of the time, it means 99% times, right? It is not like 50-50. I'm not just giving the, but 100, it is not 100%. Epsilon, even the epsilon percent difference is there, then I cannot give it as a thumb rule. That's why I said that no thumb rule, but general recommendations are given. Okay. Any other question? You can unmute yourself. So I already answered PSO and DE. What is the continuous nonlinear optimization problem? So continuous nonlinear means an optimization problem which is nonlinear, means like x1 square plus x2 square. It's a nonlinear, and it is a continuous also because x1, x2 both belongs to a continuous space. If I say that x1 can take these values 3, 1, 2, 3 or 4.5, then it is not a continuous optimization problem. It is a discrete optimization problem, right? So nonlinear continuous optimization can be applied PSO in controlling uncertainty in multi-objective. Yes, very much. But simultaneously, you answered one more problem, that if you have a multi-objective optimization problem, I suggest you don't go with the PSO, you don't go with the multi-objective version of PSO. There are better versions, a better algorithm that is called multi-objective GA, MOGA. Multi-objective GA is there. So genetic algorithm is better choice in case of multi-objective optimization. So this is just general recommendation, right? So I hope I answered the questions. Is it okay? Or if somebody has written in the chat, lot of chats are there, so I cannot read all. But if you have written here and I have not taken your question, just unmute yourself and tell me. So I hope I have answered all the questions. Is it okay? Okay. Kusum, can we stop here?
Yeah, thank you, sir. And it was a very nice presentation from all on behalf of all participants and organizing committee. I would like to thank you, sir. And definitely we have got lot of things, and we would like to see you in next session also, which is scheduled maybe tomorrow. So from all participants and organizing committee, thank you, sir.
Thank you very much. Thank you.
We can stop it at this point. So thanks.
Thank you all.
Okay. So participants, if you have not written your name on the chat, you should write your name on the chat so that it can be included. Okay, so thank you all. We will meet again at 5 and in next session. And Dr. Mukesh Saraswat is going to take the session on the 5. So best of all, and we will meet at 5.
And one more announcement is like related to your canvas. I have sent you invitation for your canvas, so you can accept it and get enroll yourself. I have mailed you. If it is
Okay.
not, then let us know. We will do it again.
Hello, madam. I have not received the mail regarding Canvas.
Okay, Ashish. Okay, okay. I will check.
Okay.
You can post your question to chat, and from there I will take it. Post your email ID. I will check it. I will check it from there. Just post it. You can, if any of you is not able to receive it, so you can mail it to me directly. I will add it. I will add it. Here I'm posting my mail ID, so you can also mail me regarding this canvas.
So can you please tell me the exam? I was not there when you explained it.
What you are asking, we are not getting.
Can you explain me about the exam? I was not there when this point was explained.
Okay. So basically, in Canvas platform itself, we are going to share all the materials related to the session, and we are also going to conduct your exam on Canvas itself. And there will be 25 questions, and each will carry 4 marks, and duration will be around 30 minutes. And all the questions are going to be your multi-objective. Okay. Is there any other question?
Hello, madam. Good afternoon, madam.
Yes.
Madam, you said to post you're going to share the link for Canvas today or some other day?
No. I have already mailed you the invitation. I have already mailed. Just check your inbox.
Okay, madam. Okay, it is one mail has come that is no subject was there, but that mail is for today's upcoming session, 5 to 6:30.
That was for session, not for your canvas.
Madam, we have not received any such type of mails from you.
Madam. No, I also didn't receive, madam.
Please check your spam folder also. It may went to the spam.
Yes, possible.
I haven't received, but I have received invitation for evening session. That sir has sent, but I haven't received any for the Canvas mail.
I'm just clarifying it.
Yes, madam. I have also received the invitation for the afternoon session only.
Okay, let me check it.
Okay, we will sort it out. Examination is on the last day. In the next session, we can sort it out by that time. So right now we are going to close this session, and this canvas thing we will sort it out. Fine. So
Okay. Why don't you give the link right now on the chat? Please give the link on chat. Canvas link on the chat.
Basically, it's the invitation. So that to be sent on your mail only. So from that place only you can
No mail is received, madam.
Yes, yes, I'm checking it. I will let you know. I will let you know.
I sent you the mail on your email that you have said.
Just a minute. Just a minute. Anjali Naik, your name is Anjali Naik, no?
Yes, yes.
Yes, yes. I have mailed you. Just I checked it. I have mailed you.
I'll just check now.
Okay, okay. Yes, I have mailed it pending.
Hello, ma'am. Hello.
From which email address you have mailed?
Just wait. I'm sharing the invitation screen. Let me do it. Then you will see your. This I have mailed you on this. Possibly my screen is visible.
Hello, ma'am. Can you check for Rahul Roy, please? Hello.
What?
Hello, ma'am. This is Rahul Roy. I also didn't receive any link for joining Canvas.
From which mail?
Hello.
From which mail we will be receiving this link? From which mail we will be receiving this link?
Kusum at the rate of IIITDMJ.ac.in.
Hello, madam. I am Sudarshan. I also didn't get any mail. I got.
Check your inbox and spam. If you're not.
Yeah, madam. I took. I checked both of them. I got one invitation mail morning from your mail ID. After that, no such mail came, madam.
Okay. So just mail me regarding Canvas. I will manually add your name in this. I will manually add the invitation if you haven't received it.
Okay. I'll send a test mail, madam. Okay, madam.
Hello, ma'am.
Request mail.
I received. Thank you.
Okay.
Hello,
fine.
madam. This is Rahul Roy, madam. Hello.
Yes.
Madam, this is Rahul Roy. I also didn't get any mail regarding Canvas.
If you haven't,
Can you check it, Rahul Roy?
Mail me. You haven't received, just mail me. I will manually add your name in your Canvas.
Ma'am, I have already mailed you. Just now I have mailed you.
Yes, then I will check it and add you.
Even I have written in this chat box also. Can I write again?
No, not required.
Okay, fine.
Madam, to which mail area we should mail, madam?
Yes, all of you do this.
Madam, to which mail ID we should mail?
I'm using
I have used the mail. I have used that mail ID which you have registered on Atal portal.
HR, that is horizontal.
I have used that mail only.
Madam,
can you put your email ID in the chat box?
Madam, can you kindly provide it in the chat box?
What?
Hello, ma'am.
Yes.
This is Piyush Raja. Please create a WhatsApp group and
that we will do.
Send the link.
Yes, we will create.
Everyone able to see this?
Madam, can you kindly provide it in the WhatsApp in the chat box, madam?
Notepad.
What you asked? What you are asking for?
Are you able to see this notepad? All of you. Are you
Hello,
able to
ma'am.
see my desktop notepad?
Ma'am, just write your email ID in the chat box.
Please do that various way of accepting the tag.
Hello, madam.
Yes, Sudarshan, I have mailed you on sbehra.04.
Right, madam. Right. Let me check, madam. And my number is 970-123-5220. 970-1.
Information you have given on the portal, on that information only we are going to serve.
Please add me in the WhatsApp group, madam.
Yes.
This is my number, madam.
Madam, I saw your email, but it is invitation for the morning. It is not a link.
Mail me. If you haven't received it, then mail me your means just mail me. You haven't received the invitation for can wash.
Okay.
I will.
Okay. I'll do that. I will do that.
Ma'am, what is your email ID?
kusum@itdmj.ac.in. I have written on the chat box.
Okay, let me check, ma'am. Ma'am, could you please, okay, Kusum @ okay, fine, got it, ma'am. Thank you.
Okay, guys, so I'm ending this session. We will meet at 5 for the next session. And these canvas things, we will sort it out. Okay, then thank you all. Bye.